Hello everyone and welcome back. In this lecture we're going to talk about the second method of saturation measurements, which is solvent extraction apparatus. And solvent extraction, basically the other name is Dean-Stark method. So if you basically check a couple of slides before this one, we were talking about basically the retort method, and then this is the second method that we will talk about. Okay, so how does it work? So this is the device you can see in this screen, and basically there is a condenser as what we had basically also in the retort method, and here is the input for water, basically a cold water going in, passing through this inner basically tube and cool this inside tube down, right? So this is the inner tube, right? And then the water leaves here, so it's basically a condenser cooling process happening there. All right, so how does it work? So basically you put your core sample here, right? And there is a solvent. This is the solvent here, right? And then there is an electric heater in this here, and you start basically to increase the temperature. So usually the solvent basically boiling temperature, should be much higher than the boiling temperature of the water. Boiling T of water. Okay. So what is the reason for that? You will see how it works. So we start to heat, and the core sample with all fluids inside it, it's basically located at the top here, which I draw it, right? And the next thing is basically which of these liquids first start to vaporize. So you have oil, right? So you have water inside your core sample, you have oil, and then at the bottom you can see there is a solvent, right? And all of them are receiving this heat, right? So the boiling temperature of the water is around 212 degree Fahrenheit. For oil is around 1000 degree Fahrenheit, right? Sorry. (1000 degree Fahrenheit), and solvent should be usually more than water, so I don't know, 300 400 degree Fahrenheit. So what happens is that first the water inside the core vaporizes, right? So once that water is vaporized, then you will have basically the water vapor go into the condenser and then condenses back into the graduated tube, which is located basically here. This is where the graduated tube is, and you have basically water condensed back, right? And then what's next? Next is basically the solvent, because solvent boiling point is somewhere between the oil and water and H2O. So the solvent starts to basically vaporize. It will move up into the core, right? So the solvent vapor will move up into the core sample. It will mix. It will mix with oil. So once it mixes with oil, then it will basically reduce the viscosity of the oil, and then it basically comes back into the graduated cylinder. And then you can basically what you will have in the graduated cylinder, let's assume this is your cylinder, you will have basically what? You will have water, right? You will have a mixture of oil and solvent. So this is not purely oil, right? This is a mixture of solvent and oil. And then you have the water. So you can measure basically the volume of the water directly from this experiment. However, you cannot measure directly the volume of the solvent. Okay, so how do you do that? So let's look at how we measure the volume of oil from these experiments. Before that, let's talk about the advantages of this method. So you can see that you don't increase the temperature all the way to 1000 degree Fahrenheit to vaporize the oil, right? And also that basically doesn't destroy your core sample. That's an advantage of this method. It's non-destructive, right, as I mentioned. And you have basically accurate determination of water saturation, as it's basically more accurate than the retort method. The reason is basically you don't go all the way to 1000 degree Fahrenheit to vaporize all the water of crystallization, and basically you don't overestimate the water saturation measurements from this method. Next disadvantage is the slow takes several days, and the oil volume, as I just mentioned, we don't measure it directly. Oil remains in the solvent, right, which is basically um, what we have there. So okay, so water saturation, you can measure it directly. That's basically simple equation of saturation. Now for oil, what you do is basically you have an initial weight of the core sample, which you have to measure it, which is mentioned with Wi in this equation, and then you have basically the dry core weight. Dry core weight is basically what? This is only rock particles. That's all you have here. Okay, no water or no oil inside this, right? So the difference is what? The difference between these two, the wet core sample and the dry core sample, is the total weight of fluids. That includes what? Includes water and oil, right? And then you subtract this from this term. This term is density of water multiplied by volume of water, which is what? Weight of water. So you are basically subtracting the total weight of fluid, and then that's minus weight of water. What does it give you? Correct, weight of oil, right? So the numerator of this equation is the weight of the oil. The denominator is density of the oil. That's very simple. So volume of oil is weight of the oil divided by density of the oil, right? So you can calculate basically the volume of oil from this, and the rest is simple. You can measure the saturation from this equation. Makes sense? That's the saturation equation. You still need to have the pore volume for these experiments, and you can calculate the gas saturation from that fundamental equation, that the sum of all the saturations should be equal to 1, right? All right, so next, it's a simple example, basically following the experiment and how we do it. It's kind of an example. First, we obtain the mass of the saturated sample, which means that this weight, which is 57 grams, for example, this is an example experiment, is basically the weight of the dry core, right? Which means just dry particles, plus weight of all the fluids, right? That's the total weight. And determine the bulk volume by non-destructive means. You can use ruler, or basically, remember we did this in the lab. So that's the bulk volume, right? Determine the oil density. So whatever oil basically we have, whatever method we use to calculate the oil density. So that's density of the oil. Place the sample in the extraction apparatus and heat the solvent. That's what the procedure was. Record the volume of water collected in the graduated cylinder, condensed bag basically. And when the reading becomes constant, we stop. This is the volume of water, for example, for this experiment that we measured from the experimental measurements, right? So after cooling, remove the core, dry, obtain dry weight, right? So that's basically weight of dry sample, right? Which we can measure it using the saturation method, resaturated the sample with the fresh water and weigh. So basically this is a weight of the sample which is 100% saturated with water, right? Okay, so let's calculate the pore volume and porosity. So pore volume, so the reason that we do part F is basically to calculate the pore volume. Remember, the saturation method was basically one of the methods we used to calculate the porosity of the samples. This part is not really part of the solvent extraction method, but it's basically for us to measure the pore volume of the sample. Okay, so this one is just to measure the pore volume. It's not really 100% part of the solvent extraction. However, you need pore volume in the solvent extraction method. All right, so pore volume saturated with water, right? 58 grams minus 53 grams, which was basically the dry weight, right? Divided by the density of the water. So this is the density of the water. This is the mass of, basically the difference between 58 and 53 is the mass of the water which basically invaded the pores of our core sample. So we can calculate the pore volume, which is 5 cc, and we did measure the bulk volume, so we can calculate the porosity as well, right? So that's our porosity. So once we have the porosity and pore volume, then we can move on. We can calculate basically the water saturation. We had 1.4 cc of water condensed back into graduated cylinders. This is our pore volume, and the resultant value is 28% for saturation of the water. And then we calculate the oil saturation, right? The oil saturation is 57 minus 53. 57 was, if you go back to the previous slide, what was 57 was the mass of the saturated sample, right? So the weight of the dry plus the weight of the fluid, right? So in part A, you can see that number. And so 57 minus 53, that gives us what? The difference between these two is the weight of the fluid, total weight of the fluid inside our sample. And this 1.4 multiplied by 1.4 was the volume of the water. 1 was density of the water, right? And the multiplication of these two gives us the weight of the water. So we are subtracting the weight of the water from the weight of the fluid, which basically gives us the weight of oil, right? So the total of all these numerator calculations is the weight of the oil. And then you divide by basically the pore volume, right? You divide by the volume of, so that was the weight, and you divide it by the density of the oil. And once you have that, then you can calculate your saturation, which is 59%, and then finally you can calculate the gas saturation. All right, and which is 30%. So please let me know if you have any questions. Make sure you do the quizzes, make sure you do the homeworks, and I will have my office hours online through Zoom. Please make sure you at least call me, let me know if you have any questions, because this is now an online system, so we need to communicate much more and put some more efforts basically for you guys so you can learn better. Thank you for watching this video, and see you in next video, I guess.